Hello and welcome to second JavaScript lecture. In the previous lecture we have covered the fundamentals of JavaScript language, but we have demonstrated it on older ECMAScript 5. Now we shift towards ECMAScript 6 and newer versions of ECMAScript specification. The revolution in ECMAScript took place about 5 years ago when ECMAScript 6 was actually released. Although this seems like a trivial increment in version, there is a huge gap between ECMAScript 5 and ECMAScript 6. And since then, since 2015, a new version of ECMAScript was released every year. So always in June there is a new specification released of ECMAScript. So now we are awaiting 11th version. Actually, since 2015, it becomes a habit to announce the new versions of ECMAScript by their year, not by their version. So now we are talking about ECMAScript 2019 and upcoming 2020. Remember, although all these versions are commonly used in normal programming life, you have to still be aware of legacy systems, because some older browsers does not support all the new features. Some older browsers doesn't even support ECMAScript 6, so sometimes you need to take special steps, some precautions, so you keep your software compatible with older browsers. However, I will get to this point at the end of the lecture. I'm not going to revise things I've told you in the last lecture because the ECMAScripts are backwards compatible, but I will focus on the differences and what's new in the newer versions of ECMAScript. First thing I would like to present is block scope. Remember, in the older ECMAScript we had functional scope, so the keyword var is actually declaring variables inside function or globally, and to declare variables in a block scope you can use a different keyword called let. Actually, I've first encountered let keyword in old BASIC. However, let keyword is not that atypical. You can see it also in Rust, for instance. So let keyword declares variables in the same manner. However, this variable is specific for the block scope only. Remember that JavaScript has slightly more complicated management of variables. So in this case, if we want to support block scope, we need to modify this mechanism. However, the only thing we need to do is that every time a block with variables is created, we need to create another activation object and push this object in front of the current scope chain. So actually it's not that difficult from the perspective of JavaScript implementation. Besides the let variables with the block scope, we also have constant variables. Actually, at the first glance, constants are no big deal because normally you don't want too many constants in your code. However, constants are rather well defining for new versions of ECMAScript because constants are important. Constants give the engine, JavaScript engine, a good hint, so the garbage collector can work more efficiently or sometimes avoid some unnecessary memory allocations as the memory can be easily transferred. Another thing regarding constants is that the constant thing is only the variable itself. So if the variable holds something which is mutable by definition, like object or an array, the object itself or the array itself can be modified. So for instance, if I have a constant object, the inside of the internals of the object, like this property, can still be assigned because it's not constant itself. However, I cannot create a new object and pass it down to this particular variable because the variable itself is constant. In other words, this is a good thing because it prevents us from unnecessarily creating new objects when the objects can be actually modified in place. Another simple yet very useful thing is template literals. Template literals allows us to create interpreted strings. Remember that in JavaScript, normal strings in double quotes or apostrophes are not interpreted, they are taken as they are. But if we want to create the string template, we can use back apostrophes, and everything which is prefixed with $ and inside curly braces is in fact interpreted and replaced in the string template with its actual string value. This is kind of similar to PHP interpreted, meaning double quoted strings. So it's a kind of hard to remember because in PHP we have double quoted strings. Here we have back apostrophes. However, the mechanism is mostly the same. Actually, in JavaScript they are slightly more powerful because in the curly braces we can have almost anything. We can have almost any JavaScript expression, so we can evaluate expressions inside. There are also some other details like extended literals, but they are not that important. The thing is that you can write binary or octal literals as numbers. The things I have presented so far are very useful, but very simple. Now we get to something much more fundamental. So perhaps the biggest difference between ECMAScript 5 and ECMAScript 6 is that the newer version has classes. Actually, these classes are kind of real, and the double quotes are actually justified. So it's just sugarcoating for a syntax you already know. So in the new syntax, we create classes as in any other language using the class keyword. And inside the class, we typically need to specify a constructor, which is responsible for initializing the objects of this class. Actually, this is just another coding for something you've already know, you have seen in the last lecture. So it's the same thing, a very similar thing as creating a constructing function. In both cases, both the normal, the new classes and constructing functions are utilized using the new keyword. So in both cases, we create objects of the class or of the constructing function using new keyword. The classes have everything we could expect. So for instance, we have normal inheritance. We can also declare normal methods inside class. So basically, this syntax seems similar to other object-oriented languages. But remember, all this stuff is just a sugarcoating for the things that are embedded in JavaScript, namely the prototyping. So when we are extending one class to another, the inheritance itself is actually implemented by prototyping. Yeah, we can call the base constructor because constructor functions are still functions. And of course, when we are declaring new methods, these methods are in fact member functions of prototype. So even though this gives the appearance of normal classes, remember there is still prototyping going on the background. You can check it out using type of operator. So for instance, if I try type of a class, I will actually get a function because the class itself is implemented as constructor function. The prototype of the constructor function exists. It's an object, and the getArea method is actually a member of the prototype object of the constructed function. Classes also offer some slightly more advanced constructs, such as static methods. So we can have a method, a function, which is static, which means it's not a member of the object, in this case object prototype, but in fact this is a member of the function itself. So it's a property of the function object that represents the class. We can also have getters and setters for properties. So we can create illusion of properties by using getter function and setter function. This is similar to creating more elaborate properties using the object create function, as I demonstrated last time. Besides classes, which are very important in decomposing your code, ECMAScript 6 also defines modules. Actually, modules are very important in basically any language, so you need to have a way how to define libraries, how to differentiate your code, how to divide your code into multiple files. So JavaScript presents this way, which is much more convenient than the ways in ECMAScript 5. Remember, in ECMAScript 5, everything had to be either in the global context, which was kind of difficult because you have to be careful to avoid name collisions, or you can create closures and hide the, let's say, unnecessary private stuff into function closures, which is not that convenient. In case of modules, we can have files which are modules, and these files explicitly say what part, what code, what constants, what functions they are about to export. So this is the interface, how they're exposing parts of their functionality, parts of their implementation. So these parts can be reused from other parts of your code. If you want to utilize a library, you can import simply everything from the library into a specific object, and then this object holds everything that was exported from the library, or you can explicitly name which part of this library you are exposing into your local namespace. So these two keywords will become local keywords in the file that uses this import. So it explicitly maps some parts of the exported things from a library into the local namespace inside your own library. There are also some ways, for instance, the S keyword, which can be used in here. So you can rename the actually exported names, so you avoid naming collisions in your local namespace. Another rather big change takes place in the realm of functions. ECMAScript 6 introduces something which is called arrow functions, and these functions tend to shorten the syntax of function declaration. So in normal JavaScript, in older JavaScript, we need to declare function using the function keyword, and of course this is the function body in curly braces, and if we want to return something from the function, we need to use the return keyword. In many cases, especially in case of callback functions or functions used with special constructs like the array map, we need typically a specific function which takes only few arguments and produces an expression using these arguments. So we can shorten this out using only the argument declaration list, then this arrow, this is why they are called arrow functions, and the expression that would normally end up in the return statement. So these two things are almost equivalent. Actually, they are not completely equivalent because arrow functions are not the same as regular functions. Arrow functions are somewhat more lightweight, so they don't have all the features of regular functions. For instance, they cannot be used as constructors. Also, there is one huge difference between regular functions and normal functions, and that's called lexical this. So these two types of functions behave differently when using this keyword. Regular functions modify their this inside based on how they are invoked. So in this case, the this keyword will refer to the items of the for each loop. However, if I would like to refer to this keyword, which is defined out of the scope of this function, I have to save it into another variable, like self in this context, and then I can refer to this variable, and this will actually work thanks to the scope chaining. In the case of arrow functions, this is much more simpler because this is resolved at lexical level, meaning that, simply put it, the arrow function actually inherits this from the outer scope. It does not modify this on the basis how the function is actually invoked. Although there are some cases where the older functions can be still useful, the trend of the programmers is actually to use arrow functions wherever possible. And remember, you can still use full-blown body if you don't place just an expression as the body of the function, but you can place curly braces there and you can place a full legitimate body of this function. So these new functions are what you should prefer in your code. There were also some changes in function argument handling. First one is that we have this new default parameter values. So each argument of the function can be provided with a default value. Of course, these defaults has to be shuffled to the right, so it's obvious which values have defaults and which not. In this case, the inc function can be called with one argument or possibly two arguments. Actually, they are still variadic, so I'm still allowed to use arbitrary number of variables. However, normal thing to do would be to call this function with one or two variables. Actually, it holds both for regular functions and arrow functions. It does not matter. I'm just using the older syntax here just to not confuse you with two new things together. Another thing is the aggregation of remaining arguments. As I've just said, the functions are still variadic. However, if we want to access the remaining arguments, there is easier way now. We can use the rest operator here, the 3-dot operator, which aggregates all the remaining invocation arguments into an array. So basically, if I call the merge function with more than 2 items, more than 2 arguments, then the remaining arguments will be aggregated in this array. If there are only 2 arguments, the rest array will be an empty array. Actually, we can use this 3-dot operator in some more cases. For instance, I can have an array of variables and I can use the spread operator. This is sometimes called rest, sometimes called spread operator based on where it is actually used. So when I use an array prefixed with these 3 dots as an argument, this will be actually expanded as the argument list. So basically this is the same thing as calling move by with these 3 arguments. Actually, similar magic can be done with strings. So if I have a string with 3 letters and I would like to expand it, I can use the 3-dot operator to create an array of characters. So in this case, the string will be expanded into individual characters, and BAR letters will be appended to this constructed array. Another syntactical feature of JavaScript which aims at shortening the code is called destructing assignments. Destructing assignments allows us to create more elaborate left sides of assignments. So instead of providing a simple variable, I can provide some sort of a template at the left side of the assignment, and this template is used to unpack structures such as arrays or objects. In this particular case, I have a regular array of 3 items, and I would like to unpack it to assign the individual items of the array into individual variables. So in this case, 3 new variables will be created since they are prefixed with the var keyword, and these variables will capture the values of the array by their position in the template. So basically this is the same thing as if I wrote just x equals 1, y equals 2, etc. I can use this for more elaborate expressions. So for instance, I can even rotate the values in these 3 variables just by writing one simple expression. In this case, this looks like a construction of an array. Actually, formally, this is a construction of an array with 3 items, and I will unpack these 3 items into this template where these existing variables will be used, but you can see that they have different positions. So x variable will be assigned to z, y variable will be assigned to x, and z will be assigned to y simultaneously in a single assignment. You can do the same thing basically with points. So if this particular function yields a 3D point, I can create 3 variables which will hold the individual coordinates from this point. I can also use renaming, so I can provide a more elaborate template. So in this case, I have a 2D point which actually holds x and y parameters, and the point also holds attributes, and one of these attributes is depth. So basically this will create again 3 variables x, y, z. The z is taken from the nested depth structure, so you can use this for nested structures as well, and x and y will be assigned to the variables with their opposite names. You can use this kind of templates also inside of context to use argument matching. So for instance, if I have a function which expects 1 parameter, I can write this template as an argument inside the function declaration, and the argument, the parameter that will be passed down when the function is called, is broken down to an array. It's casted to an array if possible, and broken down into 2 items a and b, which will be used in the body of the function. Same goes for objects over here. So this function will expect 1 object, and it will be broken down into 3 variables x, y, z, which are available in the body of this particular function. Since ECMAScript 9, we can use even wackier constructions. So for instance, we can use REST operator alongside with the destructive assignment. So for instance, in this particular case, this is a destructive assignment that breaks down, unpacks this particular object. It takes out X and Y properties of this object, and all the remaining properties of this object will be collected in another object called REST. So this basically creates another object where everything except of these two unpacked variables will be. The same goes with arrays. So in case of arrays, I'm assigning an array over here. The array will chop off a head into a separate, meaning head the first item in the array into a separate variable, and the remain of the array will be assigned to the rest variable, which is also an array, of course. Similarly, we can use spread operator. This is basically the same operator but used on the right side, not on the left side of the assignment, to expand objects or arrays in another object or an array. So if this is an object, I can use this construct to spread it into a newly constructed object. So this whole thing is a regular object literal, which has X and Y properties, and all the properties of object 2 will be expanded into this newly created object. In fact, if object 2 has X or Y properties, they will override these two properties because this spread operator is here as a last operator. So this will actually could override these two properties because it's defined later after these two. However, we can place this construct at the beginning, and then we can override properties of this object by defining other properties of our own. But having said that, there are a few examples of applications. So basically, this is the simplest way now how to perform a shallow cloning of an object. So you can see this creates a new object literal, and this will actually expand all the object properties inside the newly created literal. However, remember, this will actually don't preserve the prototype of the object. This will only copy the properties, but it won't have any effect on prototyping. Another example is an array concatenation, because unlike the REST operator, the spread operator can be used multiple times in each construct. So in this case, this array will hold all the items of first array concatenated with all the items of the second array. So this is kind of the shortest way how to write an array concatenation. So we have covered the most fundamental changes in syntax, and now we shift towards changes in basic libraries. Perhaps the most fundamental change here is the new approach to asynchronous programming. If you already wrote something in JavaScript, something serious in JavaScript, you have noticed that most of the code has to be written in an asynchronous manner. For instance, the event handlers are supposed to be resolved quickly, not take too much time. So things like background HTTP request has to be performed in an asynchronous manner, so they won't block the main loop of the browser. In this case, we are dealing with a completely new concept. Actually, this concept is typical in other languages, but completely new in JavaScript, and that's called promises. Promise is basically an object that represents one asynchronous action. So it holds the action itself, and once the action is resolved, it will hold the result of the operation, which means either the actual data, the result, or an error which was triggered or thrown during the operation. Promises are intended to completely replace the callback functions in the APIs. So in this case, mostly we will be dealing with promises that will handle asynchronous operations like the AJAX asynchronous calls. Promise itself has two possible states. It can be either resolved or rejected, meaning after it's settled, so after it's done. And resolve means the operation ended successfully and the promise itself holds the data. Rejected means that the error occurred, exception was thrown, for instance, and the promise itself holds the error message or the exception object. Perhaps the greatest advantage of promises is that they can be easily combined. For instance, if I would like to chain promises, the easiest way is to use then method, and the then method is used to attach a callback function to the promise, which is invoked immediately once the promise is resolved. Actually, if the then function yields another promise, the promise is yielded from the then, so it can be used to create a chain of promises which are invoked one after another. Similar goes to catch, which is used to handle rejection, and finally, which actually is triggered when the promise settles, no matter the result. Also, there are special methods like promise all and promise raise, which are used to aggregate promises together. For instance, promise all expects an array of promises and yields another promise that represents all the promises in the array, meaning once all the promises in the array are resolved, the final promise is resolved as well, and it will hold all the values of all internal promises as an array. So this is an example of typical promise application. So in this case, we have this REST API that fetches books, records, and the authors. And what we need to do in this case is to fetch an author record of particular book. However, in order to do so, we need to first fetch the book record, then get the author ID from this book, and then ask this API again to fetch the author record. So what we do, we use the new fetch API for HTTP requests. This already yields promises, so it's perfectly suited for our demonstration. In this case, we are fetching this particular record, and since there are no additional parameters, it means that it will be a very simple GET request. And then we'll chain an action which will be triggered once the fetch operation will be resolved. And once it is resolved, the response of this operation is passed down to this internal function, and this internal function is only retrieves the JSON body of the request. Since the retrieval of the JSON body is also an asynchronous operation because it can potentially take a long time, we also chain it in this form. And once the JSON body is retrieved, it's passed down to another then invocation. So this actually will hold all the JSON data, parsed JSON data of the previous request. You might note that I'm using the destructive assignment in the context of a function, so this will break down the object passed down and retrieved only the author ID from that object, and it will trigger another fetch operation with new value inside the URL. This fetch operation also yields a promise object, so I can continue in chaining. Again, you can see this construct which retrieves the data of the request body, the JSON data of the from the response body, and finally at the end we will get the author structure. So this will finally hold the JSON parsed structure with the author data, and finally we can do something with the author. In the second example, I would like to demonstrate how to wrap older APIs which rely on traditional callbacks into promise APIs. So in this case, we have this old AJAX GET API which actually expects two callbacks to be passed down. One callback is used in case the operation succeeds. The second callback is used to report errors. This function, AJAX promised, wraps up the old API. So you can see we remove the callback functions from here, and we just create our custom promise, which holds one function inside. And this function is the function that should trigger the asynchronous operation. So as you can see, it actually triggers the asynchronous operations. And the promise itself is passed down two functions, resolve and reject. And these two functions are actually intended to be invoked internally from the asynchronous operation once it is, as the name suggests, resolve or reject. This new API then can be used as any other promise API. So for instance, I can invoke three concurrent requests for three different PHP files. And in this case, all these three requests are resolved simultaneously. And once all three are resolved, this callback inside then will be invoked. The only difference is that since it's aggregated using the all function, the data from individual requests will be also aggregated. So I'm using this destructive assignment to actually expand all the three results, so you can see that they are aggregated as an array. Although working with promises is pretty straightforward and very simple, there is another way, better way how to deal with them, which was introduced in ECMAScript 8. The normal promises are still somewhat reliant on callback functions. For instance, if we want to change promises, we need to use then and place a new function inside then as a callback. So it still somewhat relies on callbacks. This new approach will allow us to write basically sequential code, which is ready for asynchronous interruptions. So what we have here in this example is a regular function which creates promises. Actually, it's very simple just for the demo. It creates a delayed resolve, meaning there is a given delay, and after this delay in milliseconds, it will actually resolve the promise and give the promise this given value as the resolve value. As you can see, the code is very straightforward. Now we use this new approach to deal with this promises. So first of all the functions which handle promises in this way has to be prefixed with async. This keyword actually tells the compiler, the interpret, that this function may be suspended midway. It can wait on promises, so it can be moved out from the stack when waiting. And inside these async functions, we are allowed to use these await constructs. So what happens here? First, the first line actually doesn't do anything surprising. The delay resolve will just start a new promise, start the timeout, and it's not waiting for that. It's just a very simple example, a very straightforward example of promise. So it just starts the promise, starts the delay. The second line actually also starts the delay of the second promise. However, the await here will enforce waiting for this expression, since the expression is promise, to be resolved. Actually, what await does here is that it waits for the promise, and if it's resolved, it will return its resolved value, and if it fails, if it's rejected, it will throw an exception. So in this case, the whole execution of this function is blocked, which means this function is suspended and removed from the main loop. So another function may be executed whilst this one is waiting. Once the promise is resolved, the execution will continue. So it will log the result of the second promise. And here we are again getting since the rest is holding promise, we will wait for the first one to complete, and then this whole expression will yield the resolve value of the expression. So the log function will actually log the second value, the first value of the first promise. Also, the asynchronous functions are modified in a way they are also yielding promises instead of normal return values. So if this function is to return something, the async keyword will actually wrap the whole function in a promise. So basically, this will also yield a promise value. Let's move to another topic. In the new ECMAScript 6 was introduced few new data structures. Perhaps most important are these two new collections. First one is set. It's a collection of unique items, and the second one is map. Don't confuse it with the map method of an array. So map is basically a dictionary that holds key value pairs. Normally, you can implement these two collections with an object, for instance, easy enough. Actually, you should be able to do this in no time to implement set and map using object. However, it's much more convenient to use these two collections since they already provide very convenient methods. So that it's much more readable. It produces much more readable code to use these methods instead of just writing arbitrary values into objects. And also, if you declare at hand that some variable holds a map or a set, then the reader already knows what should be inside, what's expected from this object, what's expected from this interface. So finally, we are moving into topics with lower priorities, but I would like to go through them anyways to, let's say, give you the complete impression. There is a new data type in ECMAScript 6 called symbol. So it enlarges slightly the amount of data types, native primitive data types inside JavaScript. Symbols are kind of a replacement for strings or other things you might want to use as identifiers or enum values. Symbol is created using the symbol function. Actually, this is a function, it's not a constructor. And optionally, it can get a string description, but it's just a description just for, let's say, better identifying what kind of symbol this is. However, the symbol call always yields a completely unique value. So if you just call the symbol twice, even with the same description string, it will yield different two symbols, so they are not equal. Actually, if you want to use global symbols, so if you want to use symbols which have global meaning that should transcend the modules and everything, then you can register this new symbol using symbol for function. The symbol is registered under a specific string key, so it's associated with a string key. If it already exists, the symbol is retrieved using this function. If it's not, if it doesn't exist yet, a new symbol associated with this key will be created. And there is also reversed translation. So in case you have a symbol at your hand and you are wondering if the symbol is registered and under which string key, you can ask to retrieve the key, specific key for this given symbol. So if you want to, you can also use this global registry for symbols. ECMAScript 6 also extends the way how we iterate over things. It defines generic iterator interface, which is actually pretty simple. Anything that is an iterator just has to define a specific function called next, and this function is obliged to yield another object. This object will hold a value, which is the actual value of the iterator, and done, which is flag that indicates whether the iterator has reached its end or not. If you need to create a custom iterable object, you need to specify a method which is named by this symbol. So remember, this is a symbol naming a property that holds a function, and this function yields the iterator object itself. So if somebody calls symbol iterator property of your iterable object, this method will yield an object which conforms to the iterator interface, and anyone can iterate over this object. The iterable objects, so the objects which implement this particular interface, can be passed down to the for of loops, so you can easily iterate over them. In this particular example, we demonstrate how to use iterators to generate numerical sequences. So in this case, we are generating the Fibonacci sequence as the name of the object suggests. So as you can see, to make this particular object iterable, we have to provide this property with this symbol as a name, which is this is a shorthand syntax for declaring a function, declaring a method, and we provide the body of this function. Note that we are also using this body as a place where we can put our temporary values for the iterator. So these values are not embedded in the iterator object itself, which is created over here, but they are kept in the closure of this method, which is much more convenient because no one can actually modify these values by accident, for instance. And as specified before, the iterator itself defines only the next method, and this next method yields value, which is current value of the sequence, and done. The sequence can be infinite, theoretically. However, it's much more convenient to create non-infinite sequences. So in this case, we have limited the sequence by the number 1000. So once the sequence exceeds 1000, it will terminate. And this is just a shorthand syntax how to compute next value of the Fibonacci sequence using destructive assignments. So we have two values kept in the closure, pre and car, which is shorthand for previous and current value. At the beginning, they are initialized to 0 and 1, as supposed to be in a Fibonacci sequence. So in every case, we are taking the current, the previous value is the current value, and the current value is previous plus current value. So this is just a double assignment. We don't need any temporary values for this. This is just a shorthand assignment for the advance in the Fibonacci sequence computation. Once this whole charade is in place, we can then easily use Fibonacci object in the for off loop. So in this case, we are listing out all the Fibonacci numbers up to 1000. Once it exceeds 1000, it will terminate. A more convenient way for creating sequences is provided by generators. Generator is a somewhat special function. It has also special syntax, so for declaring generators we need this particular syntax where function keyword is accompanied by asterisk. And this in fact is not a function, it's a generator object. And inside this special function we can use yield keyword instead of return keyword. Yield keyword has a similar meaning, so it yields values from the generator function, but it won't terminate the function, it only suspends the function, and when the generator is invoked next time when the iterator advances, it is resumed after the last yield and just continues the execution until next yield. An example, in here we have a infinite generator, so this is a infinite numerical sequence. Every time the generator is called, this infinite loop will yield another value and advance the internal index, which is in here, by 1. We can use the generator to create the generator object. So this is how we normally use the generator. We just invoke the generator function to get some iterable object, and then we can use it as an iterator, so manually using the next function on the G object, or we can take this object and pass it down to the for off loop. So we can use this object both ways. Next thing, and one of the last things I would like to present here from ECMAScript 6 are proxies. Proxy is a kind of a special object which wraps or monitors another object for modification. If you already know the design pattern proxy, this is a similar thing. So basically, let us have a object which is being monitored or proxied. So it's a regular normal object which has two normal properties, and its proxy is created as an instance of the proxy class or proxy constructor. It gets the original object which is being monitored, and this last parameter defines which actions are being intercepted, which actions are being actually monitored. In this case, we are monitoring all the settings of all properties. So every time a property of this object, actually of this object, because this object kind of mirrors this one, is modified, is set, then this method is actually invoked, and based on its result, the modification is allowed or not. So for instance, in this case, if the property is anything else than complete, so if you're modifying anything else than this property, there is no problem. We just return true, which means okay, we allow this setting. In case we are modifying the complete property, then we check the value, and if the value is within the range, we will allow the modification. So we want to make sure that complete property is between 0 and 100. And if it's not, the function will return false and the modification actually will not take place. So this is almost it. And there are only a few minor things. I have put them on this list. However, these are minor things, not that important. So I'm going to rush through this list, stopping only at few slightly interesting points. So at ECMAScript 7, there was this thing with exponential operator added. You might know this operator from some other languages, so I just want to make sure you know it's also there, but I've never used it, so I'm not sure if it's too much important. ECMAScript 8, actually, the important things have been already presented, and the rest are just modifications of the library, so that's important. In ECMAScript 9, there was actually this concept of asynchronous iterations. Actually, these are kind of important. but I have decided to, let's say, omit them for the sake of scope. So there are some more interesting ways how to iterate asynchronously over objects, but I'm not presenting them in this lecture. There are also some things about shared memory and atomic operations, but I'm going to present them in a different lecture. And finally, ECMAScript 10, meaning the current version of ECMAScript, presented only a few things in the libraries, but there is nothing which really merits dwelling on. Finally, I would like to summarize what's coming up next this summer. There are a few things that might be slightly interesting. So for instance, in the new version of ECMAScript, we will have dynamic module loading, import which will be resolved dynamically. That might be actually interesting because it will solve some issues with static imports which we have now. We also get big int, so we will get an integer with arbitrary precision. That's actually very interesting because if you want to implement something where you need larger precision of integers than, let's say, 50 bits, then you're in trouble. You have to do this manually or using some third-party libraries. So finally, we will get large integers. There are also some, let's say, operators which allows null coalescing. So there is definitely the normal null coalescing operator. This is actually very similar to the null coalescing operator in PHP. The only difference here, it takes both null and undefined value as the value which is being coalesced. And also we have this special operator which allows safe dereferencing of objects, arrays or functions. So this actually will safely resolve the object and access the property only if the object itself is not null or is not undefined. Also here, this will only invoke the function if this variable holds a valid function, otherwise not. So it's a easier way how to implement things where variables may be null or undefined. And finally, they specify a thing that is called global this, and this is a new way how to refer to the universal global object, to the context object. So if you're in the browser, the global this will point to window. There are other environments like Node.js which does not have the window. So from now on, all these environments, both browsers and different other environments, will have unified ways how to reach the global object which holds the global context of the script. So this concludes my overview of ECMAScript features, and now I would like to focus on things how we write code in JavaScript. There is this shift in way how we actually design code. It's not only natural to JavaScript, but you can see this shift in paradigm in some other languages. So other languages are slightly affected with this new approach as well. What I mean is that now we are trying to use more functional approach to the code design. So we are trying to retake good things which are introduced in functional languages like Haskell, for instance, and we are trying to utilize them in regular object-oriented or normal procedural languages. I will explain this on an example. So read this following code and try guess what the code does. I will give you a few moments, or you can pause the video if you like. So what this code does actually, it prints out these three numbers. Okay. However, if you read it carefully, you can somehow summarize that each of these lines, each of these executive lines inside the for loop actually has completely different meaning. They're doing something fundamentally different to the other line. So we are kind of mixing three operations, three functions together. Another problem with this code is that this for loop is actually the old style for loop, which is somewhat detached from the data, even though it's used to iterate over a data structure, over a container. So yeah, we can slightly improve the situation by replacing this for loop with for each loop in terms of JavaScript, for in loop or for off loop. That is true. However, still the for loop is somewhat, let's say, detached from what we are trying to do. So better yet, we can use the functional approach. The functional approach will actually split the operation which was bound into the body of the for loop into three separate functions. First function will just filter the even numbers from the collection. So this is one operation we need to perform. Second function provides the numerical operation. So this modifies the variables to their the values to their second powers. And the third function, the third for loop, actually takes the job of printing the results out. So as you can see now, these three functions individually perform more clear steps, so we can more easily read the code and more easily understand what it actually does. First, it removes all numbers but the even ones. Then it performs some form of transformation by creating powers of 2 of each value. And finally, it will print out all the data to the console. Basically, this concept seems to be like more wasting, more greedy, because normally this will require creating a new array which is then iterated over here, and this map function also creates a new array, and finally the last array is then printed out. So at the first glance it seems that the code will actually produce two other temporary unnecessary arrays. However, this is not our business. Our business is to provide the code as clearly as possible to other potential readers and to the compiler. Any optimizations, such as removing the unnecessary allocations or removing any unnecessary data copying, is the business of the compiler and of the interpret. And I can assure you that in this particular case, the code can be compiled and executed in a way which actually does not allocate the new arrays, does not actually copy all the data 3 times in memory. So it's possible and the compiler can do this, but it's not our business, it's the business of the compiler. So as you can see, the functional paradigm can make the code more readable, but also in some cases it may provide other opportunities. For instance, it may allow some parallelization of the code. Since all these functions presented in this example now are pure functions, so they have no side effects, they don't reach to global memory, there are some other optimization that compiler now may consider. What can we do in JavaScript? Actually, what is the support in JavaScript for the functional approach? First one you've already seen, so there are specific methods, mainly in the array processing you've already seen. Actually, most of these methods are there since ECMAScript 5, so this is a very old concept. Second thing, the ECMAScript 6 introduced the arrow functions, so we can write this code more easily in more shorter form. However, arrow functions prefer when the body of the function is only an expression. So the ideal situation is where the arrow function only produces an expression as the result. So in JavaScript, many semantic constructions may be expressed as expressions. So we can use tricks like using AND operator and OR operator to create expressions, even in cases which are probably not obvious at the first glance. So for instance, let me give you this example over here. Try to think about this example for a short time. So why I'm writing the code like this? Actually, the answer lies in here. The AND and OR operators does not return the Boolean value, but instead they return the value of the first or of the last operand. So they actually return the values of the operands. In case of AND, it will test the first operand, whether it's truthfully or not, so whether it can be converted to true or not. And if the first operand can be converted to true, then it returns the second operand. And the OR works the other way. So if the first operand is false, then it tries to return the second one. Otherwise, they return the first one. So in this case, this whole expression will actually examine the structure here, struct. And if it's a regular object, then it can be converted to true, and we will follow up to the second operand. Otherwise, the value of the struct, which can be null, for instance, will be returned to X. But the most important thing is that these operators are short circuit and they implement short circuit logic. So if the struct itself is not true, is not an object, the rest of the expression will not be evaluated. So there will be no error in here when we will try to dereference a null or undefined. If the struct is object or it's something that's truly, then I can try to dereference struct nest. And again, if this particular property of the object exists and it's another object, for instance, then this whole operand will be converted to true. So the chain will follow up and the result of the whole expression will be struct nest foo. So this is kind of a safe way how to dereference structures without being worried that either here or here the dereference will fail because we pass down a null or undefined as an object. Hand to hand with the new functional paradigm goes this immutability concept, which actually means that the programmer should not modify the data in place, but instead, when computing something new, a new copy of the modified data should be created. Actually, if you've already seen this in the functions I presented in the previous example, so functions like filter or map actually create a new copy of the array which is being processed, and the original array is intact. This actually does not have to be true on the implementation level. The JavaScript may do some optimization, so this does not have to hold at the bottom level. But if you provide this concept, you allow the compiler to do some optimizations. Second thing is, if you're dealing with this concept, you should work with pure functions only. So pure function is a function which actually only reads the inputs and have no other side effect. So it has no output and it does not modify data outside the scope of this function. There are several reasons for this concept. First one is obvious. I've repeated this a few times. So when you deal with functional programming with pure functions and immutability concept, it allows many optimizations for the compiler. It also allows almost autonomous parallelization, so the code may run much more efficiently. Second thing, we can implement things like auto-caching functions, meaning functions that actually give you some compute memory trade-off. Functions which can wrap other functions and then memorize all the inputs and all the outputs instead of computing them repeatedly. Normally, such trade-off in normal languages is very rare. However, in JavaScript, this makes sense, especially in combination with certain frameworks. For instance, if you're using React framework, the automatic caching with Redux, automated caching is actually something you really need to do, but for slightly different reason than just compute memory trade-off. And also with this approach, you can do versioning, so you can have multiple versions of the data. You can keep the track of the history of your modifications, which is sometimes useful for debugging. Sometimes it's even useful when you're dealing with things like implementing undo, redo functions in your application. Unfortunately, immutability is hard to enforce and also hard to detect. We have some constructs like the const in new ECMAScript. However, const ensures that this variable won't be changed, but if we place something like an object or an array inside this variable, we can very well modify this object internally. And we cannot even detect this easily because if we save this object as a normal reference save, not as a clone, then we can easily modify the object and this comparison will still hold. So modification of the object cannot be detected easily. We have to do some deep or at least shallow comparisons on the properties based on what we really need to, but we need to compare all the properties of the saved object, and the saved object must be a clone, not just a simple reference save. Probably the best way how to implement this is to use third-party library. I think the best, or at least one of the best libraries currently in the market is Immutable.js. It has been used for various large projects and it's supported by Facebook, I think. At the end of this lecture, I would like to focus on a few technical issues. First one is the strict mode. You may have noticed that sometimes it's difficult to write a good code in JavaScript, since JavaScript gives you a lot of leeway in the way how the code is written and designed. So sometimes you need to, let's say, use some more narrow approach, some stricter approach. You can invoke this strict mode, which actually does that, by placing use strict literal at the beginning of the file or at the beginning of a function. And inside this file or function, the JavaScript will be parsed and evaluated using this strict mode. Also, the strict mode is automatically invoked in modules and classes. So if you're creating a module or a class, which is actually typical code, you should divide your code in modules anyway. So beware that in modules, the strict mode is already on by default. In this strict mode, most mistakes or potential mistakes are actually treated as errors. For instance, accidental creation of a global variable. So missing var, const, or let keyword will lead to accidental creation of global variable, which in strict mode will actually lead to an error. Similar goes with using reserved words as identifiers. That's bad practice in any language. And there are many other details like these. If you want to know all the details, there is a link to the documentation of the strict mode in the notes of this slide. Another issue which I actually already mentioned is the compatibility issue. ECMAScript is 5 years old, but it's still not completely compatible, especially with older browsers. Actually, new browsers are almost 100% compatible. You don't have to worry about those. But if you want to have your code compatible with older browsers, you need to do something with that. The easiest solution is to transpile the code from ECMAScript 6 or newer versions to ECMAScript 5. So basically, the code is parsed and then reintegrated as a JavaScript of older version. The same goes if you want to use some dialect of JavaScript like ES6 or TypeScript. You also need to transpile these languages into older version of ECMAScript of JavaScript. Also, you may have noticed that new versions declared new functions like new array functions, new string functions. That's no problem. These missing functions can be typically easily implemented directly in JavaScript, so they can be kind of virtually implemented, and this type of implementation is called polyfill. Perhaps the most profound library for this job is Babel. So if you need to do something like this, you can include Babel library. You can use it dynamically, so you can easily introduce it to your code when just testing something or when developing. And you can also use it along with some package management, so you can use it in the compilation of your project. When you divide your code in modules or you are using third-party libraries, which is both good things actually, then you run into some problems with the transpiling. Actually, modules cannot be so easily transpiled because there are some problems, some issues with naming collisions. So what you need to do when dealing with modules is you need to actually bundle them. And the bundling is kind of a easy compilation, so you just aggregate all your modules or all your files into one bundle, into one script file, and all the necessary dependencies, everything has to be settled, so all the parts of your libraries are initialized in proper way, etc., etc. This bundling typically goes alongside with some other modifications like minimization. Minimization is a process when you replace all the variables with their shorter form. So the minimization actually shortens the code. It removes all the unnecessary comments and white spaces and stuff like this. So the final code, which is actually loaded into the browser, is much smaller than the actual code you are developing. And as mentioned in the previous slide, this bundling typically also includes the transpiling. So if you need the compatibility, you can also handle transpiling alongside with bundling. There are several existing libraries for that. Perhaps the most often used one is the Webpack, or Browserify. This is also a very popular library. So if you're interested in these functions, I would suggest trying these two libraries. When developing a JavaScript code, it's a good idea to use some form of linter. Actually, linter tools have been introduced to already in the PHP courses. So this is the same thing. Any interpreted language which is not directly compiled can benefit from having some sort of analyzer which evaluates, verifies your code during the writing, during the development. Actually, I wrote here that there is no compilation in JavaScript. There is no compilation, but you can have transpiling and you can have bundling. So sometimes you may let's say avoid using linter because you already compile your code or you bundle your code, and during the bundling there is some form of verification. Nevertheless, every tool that checks your code is a good tool, so it's a good idea to use linter anyways. There is ESLint, one of the most popular linters for JavaScript or ECMAScript. It's actually pluggable, so it can be introduced in most IDEs. For instance, in my favorite, Visual Studio Code, it already exists as a plugin, so you can easily deploy it there and benefit from the error checking your JavaScript code. That's it. Thank you for watching. Now you are supposed to know almost anything and everything about JavaScript. If there are any questions, you can post them in the discussion beneath this video on YouTube or just send me an email.